For more than a century, gasoline-powered cars have dominated our roads. The internal combustion engine shaped industries, economies, and even city design. But today, we are witnessing one of the biggest technological transitions in transportation history. Electric vehicles, once seen as futuristic experiments, are rapidly becoming mainstream. The question is no longer whether EVs will grow, it's how fast they will reshape mobility. The shift towards electric vehicles isn't random; it's a result of multiple factors coming together at the same time. Climate change concerns have pushed governments to reduce carbon emissions. At the same time, advances in battery technology have made EVs more practical and affordable. Add government incentives and massive investments from automakers, and you have the perfect condition for disruption. What we are seeing today isn't just innovation, it's a revolution in motion. One of the biggest drivers is environmental policy. Countries worldwide are setting deadlines to phase out gasoline cars. Meanwhile, battery costs have dropped dramatically over the past decade, making electric vehicles more competitive in price. Governments are offering tax benefits and subsidies to encourage adoption. At the same time, major automotive companies are investing billions into electrification. This combination of regulation, economics, and technology is accelerating EV adoption faster than ever before. If we look at global EV sales over the past few years, the growth is exponential. What started as a niche market has turned into a rapidly expanding global industry. Particularly after 2020, EV adoption surged worldwide. This isn't slow, gradual change, it's a steep upward curve. This trend suggests that electric vehicles are moving from early adoption into mass market acceptance. Unlike traditional cars, electric vehicles are mechanically simpler. Instead of a combustion engine with hundreds of moving parts, EVs use a large lithium-ion battery pack and a electric motor. When the driver presses the accelerator, electricity flows from the battery to the motor, delivering instant torque. There's no gear shifting, no exhaust system, and no fuel tank. This simplicity reduces maintenance and creates a smoother driving experience. One of the smartest features of electric vehicles is generative braking. In a traditional car, braking wastes energy as heat. In an EV, braking actually captures some of that energy and converts it back into stored electricity in the battery. This increases efficiency and extends driving range. It's a simple idea, but it represents how EV technology rethinks energy use entirely. Despite the progress, challenges remain. Charging infrastructure is still developing in many regions, and range anxiety continues to be a concern for drivers. Battery production requires materials like lithium and cobalt, raising environmental and ethical questions. Charging also takes longer than refueling at a gas station. These challenges don't stop progress, but they do shape how quickly the transition can happen. The next wave of innovation is already underway. Solid-state batteries promise longer range and faster charging. Ultra-fast charging technology could reduce charging time to just minutes, and as artificial intelligence advances, electric vehicles are increasingly integrating autonomous driving systems. The car of the future may not just be electric, it may drive itself. Electric vehicles are not just another automotive trend, they represent a fundamental technological shift in how we power transportation. While gasoline cars won't disappear overnight, the momentum behind electrification is undeniable. The real question is no longer if the transition will happen, but how quickly it will redefine the roads we travel every day.